Put your name, date, and period, please, on the top right corner. Today is October 23rd. We will be turning in our portfolios the first week of next term, so that's in 2 weeks. So at the end of all your notes, what are you supposed to have? A summary. If you haven't been doing a summary, you have some work to do. Okay, at the end of each of the notes, you should be writing a summary, which the first couple sentences of the summary should answer the essential question that we write every time. We did a whole day on this. A whole day of how you write summaries. Okay, well, you need to write a summary. Okay, so our essential question for today is, when we solve quadratics, what do the answers represent on the graph? When we solve quadratics, what do the answers represent on the graph? Okay, we're going to go over 2 different ways that could be used to solve quadratics. The first way is solving by graphing. Solving by graphing. Okay, our first example today is x squared minus 16 equals 0. X squared minus 16 equals 0. So how do we graph these quadratics? We've done this for a couple of days. How do we graph quadratics? What's always required to graph quadratics? Marcos? The x and y chart or table. Good. The x and y table. So that's what we need to do. We're going to do an xy table. Okay, let's start at -3 to +3. And when we solve and plug these in, how do we know that they're actually solutions, which are called roots and zeros and x-intercepts? How do we know when we actually have a solution? Rone? Oh, you're saying like the vertex, how we get repeated numbers? How do we know? Because it says, when we solve quadratics, what do the answers represent? So an answer, when you solve a quadratic, we have to get an answer. What does that answer mean, or what do we look for? Jared? It has to equal a certain number. So when we have a graph, the solution is where the graph crosses the x-axis. And if we're on the x-axis, how high are we? What's our height if we're on the x-axis? 0. So that's how we know which ones are solutions, is when we plug in these x values and we get 0. Okay, so let's plug them in and see which ones come out to be 0. So here's the work column. Wherever there is an x, you put parentheses. So parentheses squared minus 16. And even right here, we're looking for it to be 0. Okay, so our first one to plug in is -3. Yes? So I'll plug in -3. What's -3 squared? And then minus 16. You can even do that without a calculator if you don't have a calculator. -3 squared. Okay, well, what's -3 squared? Times. It means -3 times -3. So tell me. 9. Okay, and 9 minus 16. What's 9 minus 16? Negative 7. So that's not a solution because it doesn't equal 0. It's a point on the graph, but we're trying to find which points cross the x-axis or touch the x-axis. Okay, so I'd like you to go all the way through the chart. Plug in the next one. Plug in negative 2. And then plug in negative 1. Fill in the whole chart. All the way down to positive 3. Fill in the whole chart. Hey, turn to your neighbor, please, and share your chart. Make sure you guys got the same. All right, Parker, what did you get when you plugged in negative 2? Good. We should have gotten negative 12. Okay, Kelsey, what do you get when you plug in negative 1? Madison, would you mind closing that door? There's some loud people out there. Plug in negative 1 squared minus 16. Good, negative 15. Okay, then we plug in 0. Law, what do you get when we plug in 0? Negative 16. Okay, positive 1. Bo, what do we get when we plug in positive 1? Oh, we have a repeat. So if the negative 15s are hugging the negative 16, that means negative 16 is called the vertex. Once we start seeing the repeats, we've found the vertex. Okay, so these two are negative 15, which means the next two have to match. So this, when we plug in positive 2, it matches negative 2. So they'd be negative 12. Those two match. So the next two match too. So what's our last value? Negative 7. Okay, did we find a solution? No. But I think we're really close because look at the pattern. Negative 16, negative 15, negative 12, negative 7. Aren't we getting closer to 0? Yeah, we're getting closer to 0. So I bet you if we tried one more or two more, we might find it. So everyone plug in positive 4 now. Plug in positive 4. Hey, look at that. 4 squared is
0. Oh, wait, sorry.
16 minus 16 is 0. Dun, dun, dun. We found a solution. And isn't there another solution? Because we know this is symmetric. Negative 15's match, negative 12's match, negative 7's match. So what else would be a solution? I bet it would match. Negative 4, 0, which is kind of why I left a space there because I knew it was coming. Okay? Yeah, smart thinker. Okay? So we found our solutions. Our solutions are points. Now make sure you actually write it as a point. Make sure to be parentheses. Negative 4, comma 0, close the parenthesis, and positive 4, comma 0. Okay, and let's graph this now and show what we just discovered. Before I write the graph, I want to analyze the points I'm going to be graphing. Look at the x column. What's the smallest x? And I think there's some negatives. The smallest x is negative 4. And the largest x is positive 4. So we have both negatives and positives. And analyze the y's. What's the smallest y? Negative 16. And the largest y? Oh, are there any positive y's? No, there's not. So I don't have to make my chart like this because I just noticed there's no positive y. So I can take my x and I can make it as an upside down t because my data is all underneath the x-axis. So you can make your graph fit your data. So I'm going to do it as an upside down t. Make sure you put arrows and label your axes y and x. Okay. On the x-axis, we need to go out to -4, so try to evenly space these intervals and label -4 to +4. On the y-axis, we have to go all the way down to -16. Who wants to draw -16 lines? Or 16 lines? Anyone? Anyone? Okay, you guys can do that. I'm a little more lazy, though. So what could I count by instead of counting by ones? I could count by twos. That would work. You can do, if you want to count by ones, you can do it by ones. It's not a big deal. It just takes a little more work. 2, 4, 6, 8, 10. But if I'm counting by twos, I have to label it so Ms. Gray knows what in the world I was trying to do. -10, -12, -14, -16. See how I've labeled a few of them so I can figure out that the graph is counting by twos on the y-axis. Okay, now we're going to go plot. And on the other classes, when I was checking their graphs for a previous assignment, some people are only plotting 1 point or 2 points and then drawing a U through it. That's not enough. We need to graph at least the 7 points, which in this case we're going to do 9 because we had to go a little further. We need to graph all of these points. They should be clearly marked. Okay, so our first one is -4, 0. Angelina, starting at the origin, how do I plot the point -4, 0? How do I get to that point? How many? Go to the left, -4, and then how many do I go up and down? None. So there's the first point. To make it large enough that we can actually see it. Okay, then the next one. We go left, -3, and then where do I go? Where? Maya? Down to -7. Now -7 is between -6 and -8. Make sure your points are large enough that when you draw a curve through them, you can still see the points. -2, -12, -1, -15, which is between -14 and -16. 0, -16 is the vertex. And then we can use symmetry for the rest. Oops. And what type of a shape goes through these? A U. Do you remember the vocabulary word for that U? Parabola. Good. Now it's very important at the bottom where the vertex is, don't make it a V. Don't make it sharp. It needs to be curved like a U. Because a V graph is a different type of graph which we'll learn about later on this year. And notice I always put arrows on the ends of my parabola because it does keep going up and up and up forever. So the most important points right here is 4, -4, showing the intersections and the vertex. Make sure those are very clear and everything's labeled. Are there any questions of how you find the solutions by graphing? Okay. The next way is to solve by taking a square root. We're just going to do 2 solving by square root, and that's the end of our notes. Okay? We're going to solve by taking, well, it depends on a person's preference, square root. We'll make that singular. Okay, example 2. M squared minus 36 equals 0. Example 2 is m squared minus 36 equals 0. Okay, we can find the solutions, which are the same thing as roots, zeros, and do you remember the other vocabulary word? Roots, zeros, solutions, and These points are on what axis? X. So these are called x-intercepts. So we have 4 words that mean the same thing. These points we've just plotted here and found. These are called roots. They're called zeros. They're called solutions. And they're called x-intercepts. And unfortunately, we use all 4 of those names. And you just have to be familiar with all 4, and they represent the same thing. Okay, so on example 2, we don't even have to graph to find those. We could just solve it, which is going back to pre-algebra and solving for the variable. How would we get m by itself? Oh, close. There you go. The inverse operation of subtracting 36 is to add 36, right? But we must do it on both sides, because that equal sign divides the 2 sides. So these cancel out, and we're left with m squared equals 36, which almost looks like m is by itself, but it's not quite by itself. It's with another m. Okay, so there's 2 m's. How do we get a single m? You don't divide. We have to do the inverse of squaring. Jonathan, do you remember the inverse of squaring? Olivia? There you go. We're going to take the square root. That's the inverse. Square root both sides, which just leaves us with m equals. Now what's the square root of 36?
6.
Is it?
Yeah. 0.6.
What? 6 is half the answer. What's the other half?
6.0.
Negative 6. Isn't it true that negative 6 times negative 6 is also positive 36? So, nope. In our case, because parabola is going to cross the graph twice, most of the time, we have a positive and a negative answer when we take a square root. Because it is true that 6 times 6 is 36, but it's also true that negative 6 times negative 6 is 36. There's 2 answers. That is solving by the square root. Yes, you need both. Okay? Alright, well let's try it one more time on a 3rd example, and then we're done with our notes for today, and we can work on our homework. Okay? The last example. Okay? The equation's a little more complicated, but we can still solve by square roots. So it says 2r squared minus 32 equals 0. Yeah?
Alright, so for the plus and minus 6 thing, what happens if we accidentally put minus plus? Would you count it wrong?
No.
Has to count it wrong?
No.
But is it a negative or a positive?
Right here?
I want that to be
In
the
the
question.
That says minus 32. Yeah. Okay, try solving it. Work it out on your paper using inverse operations. Here's a hint. When you're solving an equation that has multiple operations, you should try to get rid of addition and subtraction first. After you get rid of addition and subtraction, then you work with multiplication and division. And in our case, there's probably a square root in there. But first, get rid of addition and subtraction using inverse operations. Let's see how we turned out. Elijah, what do we do first to solve for r? Yep, be a little more confident, you're correct. Because those are inverses, right? Subtract and addition are inverses. Okay, so those cancel out. We're left with 2r squared equals 32. Amina, what do we do now to get r by itself? Good. Divide both sides by 2, because this 2 is actually being times to r squared, right? So the inverse of multiplication is division. 2 divided by 2 is what number?
2.
No, Victor. 2 divided by 2 is 1. So we get r squared equals, so what's 32 divided by 2? 16.
I got one of them right.
Yep, half of 32 is 16.
Can you do it more?
We're not done, right? What do we do now? If you got a decimal, it's not right.
Square root?
Now we have to get rid of the squared, which is taking the square root. So R equals...
4.
Uh,
2. Negative 4. And
that's called plus and minus 4. That's using the square root. Solving by taking the square root. Do you have questions on solving? Okay, there's a question. Can I have everyone quiet so I can hear, please? Okay, so that's a good question. So he said, what happens if it was this instead? So what would the inverse be? Subtract 32, which gives us 2r squared equals negative 32. Do we still divide? You don't do the square root until the end.
I did that.
Okay, here's a question though. Because we changed the operation, because he was just curious, what is the square root of a negative 16?
Positive.
still full.
And our square root has to be what number times itself is negative 16? 4 times 4, is that negative 16?
No, 4 times negative. Oh, that's a tricky.
It is a tricky. What's negative 4 times negative 4? Is that negative 16? Ah, we're actually learning about this later on this year. This is a number that's not real. It's called imaginary. This answer would be plus and minus 4i. It's an imaginary number. Don't worry, we don't learn it until like a couple months, but he asked about it. But you can still do it, it's just imaginary.
I wait to imagine the numbers.
Okay, here's our assignment. Page 741, numbers 1 through 16. Remember, we're going to do this on paper, not in our books. The problems are in your books. The problems are in your books, but please write your work and your answer on paper